Hello, I'm Brandon Voignier, and today I'm going to be talking to you about carbon sequestration. We've all heard about it, we all know it's a good thing, but do we really know anything about it? Well, today, carbon sequestration in trees is the topic. See, what happens when trees take carbon out of the air? That carbon actually turns into wood and wood products. The stem of the tree holds a large amount of carbon and is the main structural component for these trees. A lot of times, these trees, because wood is so valuable, these trees are planted into plantations. We have in North Carolina plantations upon plantations, acres and acres of southern yellow pine, more specifically loblolly pine. It is a specific type of tree that has been grown for its wood value and wood quality for years. It's actually probably the wood in the 2x4s that is holding your house together, that's in the wall to your left and to your right. So if we were to take this growth and put it on a graph, we would see a growth versus time graph. These trees, on an individual level, on a year-by-year basis, have a very predictable curve of growth. They start out really fast and race to a peak. Then that peak falls to a valley, and then it quickly levels off. Now, this growth is what we call a annual increment growth, and it brings us and shows us something very interesting. If I was to graph this in another way, and instead of putting growth on the y-axis, and I was to put yield on the y-axis, it's the same different graph, but it tells the same story in a slightly different way. What happens is the trees grow very fast, and then there's a point where they start to level off. This level off point is a key point in maintaining forests, and especially forests that are managed by silviculturists. This point right here that is marked is generally where these pine plantations are harvested because they are no longer profitable, or they have lost the amount of profitability that will make them competitive with other forms of investments like the stock market. So what is so special about this point here that I've decided to put a red arrow on it? Well, I'm glad you asked. This point, it represents that time, like I said, where the forest becomes less profitable. But the reason it is less profitable is because the growth of the trees has slowed to a point to where it's starting to reach that level off. Now, if we were to look at this in another way, yield is just a fancy term for the amount of carbon that the tree has pulled out of the atmosphere and solidified to form its structural components, or its carbon sequestration. In an old growth forest, it looks very similar to this. You have a fast increase and then a slow level off. Finally, we get to a point where the forest does not really create or return any carbon. It will, on some years, accept more carbon than it returns, and on some years, it may return more carbon due to metabolic processes into the atmosphere than it actually takes. So, if we were to take this total carbon sequestration graph and, wow, it looks very similar to something that we just did. Let us remove the wood from that portion and put it into wood products and plant new trees on the same plot of land. This happens to be exactly what forest managers do. They remove the trees after they stop growing to a point where the yield is slowing down, and then they plant more trees on them. And then this is a way to prevent that plot of land from actually ever leveling off in its carbon sequestration. So the more we remove, and as long as we replant with a fast-growing species of trees, then we can continue the cycle of carbon sequestration. Advancements are being made every day, and trees are growing faster and faster, especially these commercially productive ones, because a tree that grows faster makes more money. But for us, who are concerned about the earth, a tree that grows faster actually sequesters more carbon. And the more carbon we can feed into these trees, the happier earth we have. So here's the question for you to think about. Why are faster growing trees better for sequestering carbon? Thank you for listening to my video, and I hope you have a wonderful day. Bye-bye.